Good afternoon, everyone. Welcome to this talk hosted by SciWEM's Central Southern Branch on non-recyclable waste treatment, an insight into an energy recovery facility. Hopefully you're all on the right call. It's really nice to have you with us this afternoon. Just to introduce myself, I'm Lewis Purbrick. I'm a Senior Flood Risk Advisor for the Environment Agency in Thames area. And I'm also a committee member for SciWEM's Central Southern Branch. Before we start on the meeting proper this afternoon, on the talk itself, I'm just going to run through a few SciWEM notices. The first one is I've been asked to draw your attention to SciWEM's declaration on the climate and ecological crisis. And you can see further details of that on the SciWEM website. Really worth having a look at as it underpins everything SciWEM is doing at the moment. I also want to draw your attention to the fact that the Early Careers Network steering group for SciWEM is currently on the lookout for new members. So if you're early in your professional career within the environment or environment sector, and you're already a member of SciWEM and you're interested in steering the future of the Early Career Network, then applications for that need to be in by the 23rd of September. And we've got a lot of events coming up as we go into the autumn and into the winter. I won't go through them all, but just to flag a couple that we've got coming up soon. On the 20th of September, we have a site visit. Derby, our city, our flood. So an opportunity to get out in Derby, out there in the real world. And that's hosted by East Midlands River and Coastal Group. And then on the 4th of October, we're back online, back in the virtual world for a webinar, an introduction to global scale flood modelling, which promises to be a really interesting talk and discussion. We are also coming into annual general meeting season, it seems. So we've got quite a few AGMs coming up across SciWEM, including the Central Southern Branch AGM on the 3rd of October. So if you are a branch member, please put that in your diary. For the dates of the other AGMs, see the website under the events section. The AGMs are really the opportunity to get involved if you want to join your local committee or assist in other ways. So do have a look at those. I'd encourage you to get involved and contribute to your local SciWEM branch if you can. I also wanted to give a plug to the Planet Possible podcast, SciWEM's own podcast. If you haven't come across them yet, a really good, interesting range of topics covered on those, and they're available via the website or via streaming services. Then finally, just to mention that this afternoon's talk is open to both members and non-members, and everyone is very welcome. But if you're not already a member of SciWEM and you're interested in joining, I'd really encourage you to do that. It's a fantastic way of developing your career and furthering your professional development and expanding your network across the environmental sector. Yes, I'd encourage you to go to the membership section to look at all the various options open to you. That's the notices that I wanted to run through. Just before we come on to the talk, a couple of bits on housekeeping during the talk. We will have the chat function open, but please just use that if you're having technical issues. We've got Olga and Natalia on hand to try and help you if you're having any issues. And we'll also be using the chat to post links with further information referred to in the talk. So do keep an eye on that. But if you have questions, and this is important, if you have questions, please use the question and answer tab on the Zoom call. And then we will be going through questions at the end. You can also vote up questions. So if you see a question that you'd like answered, vote it up, and we will try and come to those first at the end of the call. So on to today's main event, the talk itself. Today's topic is non-recyclable waste treatment, an insight into an energy recovery facility. I'm really looking forward to this. As part of my role at the Environment Agency, I was actually consulted on the planning application for the Ardley Energy Recovery Facility in Oxfordshire. So it'll be really good to hear, how it's now operating and everything that's happening there. And we also have lots of really interesting talks at SciWem, many of them water-based. So it'd be really interesting to hear from colleagues in the waste sector this afternoon. So something a little bit different and really interesting this afternoon. So I'm certainly looking forward to hearing this afternoon's talk. It gives me great pleasure to introduce this afternoon's speakers. So we've got Jess Baker-Pike, Learning and Visitor Centre Manager for Viridor at their Ardley site in Oxfordshire. Jess has a Master's in Waste Management from the University of Northampton, and Jess's philosophy is don't waste anything, and she brings that passion to her work at the Energy Recovery Facility. We've also got with us this afternoon Innocent Mfomba. Innocent has a degree in biotechnology from FUTU in Nigeria, and a master's in environmental sanitation and technology from Ghent University in Belgium. And he is now the Environment, Health and Safety Manager at the Ardley site with Viridor. So I will now pass you over to Jess and Innocent for this afternoon's talk. Thank you very much.
Thank you very much, Lewis. Yeah, and my philosophy definitely is not to waste anything. And so in terms of that, I'm not going to waste any time and I'm going to get straight in. But it's really great to be here today. Any opportunity to talk about, waste and recycling and how to handle materials and the best way to is always a wonderful thing. So as it's lunchtime, I'm imagining that some of you at least are eating your lunch, and the food that you're eating, maybe, it is in washable packaging, maybe it isn't, maybe it is something that's recyclable, like this plastic drink bottle. Some of you may be using items that are not right for recycling, and we're going to open your eyes today as to what can happen to those non-recyclable materials. Things like this biscuit wrapper here, it's got both paper fibers and plastic as well. Things like napkins, don't know if you can see that, where the fibers are just very short, so they're not right for recycling. So things like that, what happens to them once you put them into the bin? So the structure of our webinar is, I'm going to talk to you first about Viridor, our purpose and our operations across the UK. And then we're going to focus on the case study of Ardley Energy Recovery Facility and our operations here. I'll hand over to Innocent at that moment, and he's then going to go on to talk about permitting, the environmental reporting and monitoring. And then within the hour, there'll be time for Lewis to help mediate and monitor the question and answer session for us. So it's very fitting that this talk is included in SciWem's Climate Adaptation and Resilience series, because the waste sector, which handles approximately 222 million tonnes of waste a year, has evolved, through huge investments in this kind of operational facility, energy recovery, otherwise known as energy from waste facilities, as well as increasing recycling. And those efficiencies of treatment of material, have saved, according to the Environmental Services Association, who estimate that it's saved and reduced greenhouse gas emissions by about 46% since 1990. And that is an enormous reduction. Viridor has played a significant part in this reduction. So Viridor operates across the UK to treat non-recyclable or residual waste, as it's called, and to recycle plastics. So we have the largest fleet of energy recovery facilities with a capacity to treat over 3.5 million tonnes of non-recyclable waste, which equates to about a quarter of all the inputs by tonnage through this type of treatment here in the UK. And through doing that, we're outputting energy and in the form of electricity, which is particularly, good at the moment in terms of resilience. It's also good for the United Kingdom, and that's enough to power over 630,000 homes. So that's an awful lot of energy coming out of the treatment of non-recyclable waste. So what are we aiming for? Well, our purpose is to build a world where nothing goes to waste. Which aligns perfectly with my philosophy. We published our environment social governance strategy back in July. This graphic from it illustrates how we're going to reach this goal. And it's working through our near-term vision, which is to be the UK's leading innovator of resource recovery and recycling, so transforming waste for a climate positive future. And you can see below that there are really two strategies that underpin this vision, how we're going to get there, and they are interlinked. And they are our carbon and our circular economy ambitions. And we are already working on these, of course. We cannot reach these without our networks with professionals, so people like yourselves, and also our communities. So my role is about bringing people together to inform and enable communities to put basically the right stuff into the right bin. And I've hosted about 20,000 people to Viridor sites. Anyway, it's great to speak with you, as I said, and have this opportunity today. So of these two strategies then, our carbon ambition, which was published actually in May 2021. And essentially there's 5 steps towards it. And these cover and range from increasing our efficiency of our processes, reducing plastics in non-recyclable waste that we treat, using carbon capture technology to lock away carbon dioxide emissions, and increasing the efficiency of energy outflows from our sites. So through these steps, we will achieve net zero by 2040 and become net negative beyond this date. So our largest site at Runcorn on the Mersey is included in a carbon capture and sequestration project that was announced just after COP26, which means that it can lock away approximately 1 million tonnes of carbon dioxide a year. The other interlinked strategy is our circular economy ambition, and we're currently working on projects. So from the top left clockwise then, to end plastic waste exports, to drive an infrastructure market for recycling, expand operations to hard to recycle materials, extract plastics from general waste and drive novel reprocessing techniques, and drive innovation and regulatory improvement to achieve complete plastic circularity. So we have finished commissioning of the largest polymers recovery facility in the UK, and that is at Avonmouth. It's powered by an energy recovery facility there, and it exists to treat over 80,000 tonnes of plastic packaging a year. So reducing plastic exports by an estimated 8% since it was fully commissioned. So, and recycling more decreases environmental impacts, of course. So, for example, the Waste Reduction Action Programme has calculated that using recycled polymers to manufacture drinks bottles uses approximately a quarter of the energy it takes to make a drinks bottle from crude oil. So significant savings and reductions in terms of environmental impacts. In addition, we are calling for a rationalisation of plastics used for packaging of food and drink. And we want a short list of 4 plastics. So those are which melt most easily and can be most easily recycled. Of course, working in the waste sector, and I'm sure you're aware of this, there are lots of legislation that we must comply with. The principles come from the Waste Framework Directive in 2008, and the core principles of our activities come from our duty of care, that we do have to move materials up this waste hierarchy. So I see this hierarchy as rating efficiency in materials processing. We aspire, of course, to a circular economy, which is at the top of the hierarchy. So at the top then, as consumers, we can all make choices about what we buy. So, we can refuse to buy certain bits of packaging. I don't know if you can work out the brand of this packaging I'm holding up, but it packages crisps using plastic, foil-lined fibres, cardboard, metal. Really, there are more efficient packages for crisps that use a lot less materials and can be now collected for recycling across the UK. So we can make choices as we buy things, and working then with designers to rethink designs so that materials that are made, things that we do then buy, can be processed right through that whole life cycle, including what happens once it goes into a bin. So we work with designers. Samples of material are sent through our processes, for example, our polymers recovery facilities, to make sure that they can be separated effectively. So along with those at the top of the hierarchy is to reduce, and really that is just buy what you need. That is the most important thing. As a company, we have our procurement teams that are managing that for us, but we're all individuals. We all have the opportunity to make choices, as I say. The next level down then is to reuse. And for us, it does mean keeping things in use for their designed purpose. So that is fixing things. And again, at work here, of course, on a large industrial site, we have technicians, and their role is day in, day out to monitor parts and fix them as necessary. And as individuals, we've got an image of a bicycle you can see there. It's about mending punctures. It's about keeping the things that we've already bought in use, and using the third sector, so charities. So for example, the charity mega stores, for furniture and that kind of thing is a very good way. The next level down is to recycle, and Viridor focuses on plastics very much. As I said, we are calling on government for a shortlist of recycled materials in terms of plastics, and they are drinks bottles, so polyethylene tetraphthalate, the kind of milk bottle material, which is high density polyethylene. We've got low density polythene as well, which is plastic bags and other foods, maybe frozen foods that are packaged like that, and then polypropylene for pots, tubs and trays. Those materials are the ones that melt most easily. And then hopefully you can see I am holding up some pellets. These are recycled from milk bottles. That's high density polythene. And then we also sell flakes, which is probably less visible as well. So very, very much those levels are more efficient. But what we can do with the things that are not right for recycling is we can put them through this energy recovery facility process and get all the energy back into our grids, not leaving the legacy that happens when you dispose of materials to land. And that's really some of the advantages. Of course, having a building and a facility means that we can control, for example, for odours and emissions through air suction through within the building itself. And that is hugely important when it comes to protecting the environment, because when landfill cells are in use, despite having a daily cover, which is what you can do to try and prevent emissions. Of course, there are emissions from the processes, the anaerobic processes of biodegradation, which mean that methane is being released. And methane has, as standard, counts as 25 times worse as a greenhouse gas than carbon dioxide. As some people are actually saying that really, because of its longevity in the atmosphere, it's really more like 80 times worse. So, you know, controlling for those anaerobic processes, having a building where we can use air suction to reduce those kind of gaseous emissions is really important in terms of preventing environmental degradation. So we operate the largest fleet of energy recovery facilities in the UK. Here you can see a view of them. They operate across Scotland, Wales and England, and most of our facilities have two line processes, and that gives us both the capacity and contingency then. They normally treat within approximately 300 to 500,000 tonnes each per year, so significant amounts of materials being received on a daily basis to all sites. So as I said, Runcorn is our largest, and that treats over 1 million tonnes of non-recyclable waste. It takes waste from Manchester and the surrounding area, and it's run as two businesses. So Runcorn is going to be our first site to have carbon capture technology installed. Ardley Energy Recovery Facility then, it's the place where Innocent and I are both sitting right now and where we work. So it's located just south of Junction 10 on the M40. So it's south of Banbury. So driving around the area, as I'm sure you do, you may have seen it clearly from the M40. So the history of the site is that it was a limestone quarry, and waste has been brought here since treatment since about the 1960s. So you can see some of the history from this site, from this aerial photograph, which was taken during the commissioning stages of the energy recovery facility. So landfilling started under dilute and disperse legislation. And then, of course, then when landfill, the legislation changed, so the engineering was used, cells were then built. You can see then some of the liners there in this image, and they were used then to contain and control the waste in a more effective way. But as I say, the advantages of having the building that we operate in are that we can control the air within the building, and that's much better in terms of containment and controlling the gases. So the energy recovery facility was completed in November 2014, and it's been treating waste on this site since the landfill became closed in November 2014. So in Oxfordshire then, we are diverting at least 95% of all of Oxfordshire's non-recyclable waste from landfill, and we generate enough power here for about 60,000 homes. That's about a fifth of the whole county. So these things are expensive to build. So this one cost £205 million. And that kind of capital then was enabled because we have a long-term contract with Oxfordshire, which is for 25 years. So we're 7 years into that contract now. And under our permit, we're here to treat 326,300 tonnes of waste every year. We use the energy that comes out to power our facility first, and then we export 27 megawatts, that's continuously under a contract to the grid. About 40 people work here, and that's running the operations, and the visitor centre is a very important to this contract, enabling our community to come and see what we're doing and understand, you know, the difference that they can make in handling waste resources. So if you'd like to book a visit, I'm encouraging Lewis that CIWEM would book a visit, but if you want to come as an individual, we do have a location, hopefully that's been put into the chat now, on our website, which is the start of the booking process. So here's an image of the non-recyclable waste, the kind of thing that's being delivered to us day in, day out. You can see that it incorporates a huge range of different materials, so textiles, paper, cardboard fibres, polymers and metals. And so some of the material could have been recycled. So here in this image, hopefully you can make out there's actually 2 plastic drinks bottles there. You know, putting plastic into the right place for recycling is, really important in terms of treating that material efficiently. And plastic bottles are collected right across the UK for recycling. So the best thing to do to prepare plastic bottles, because I'm imagining that you are like me wanting to present them in the very best way, is to give all bottles a rinse. Get that liquid then that you've used to rinse it out, dryish, and then squash them to get the air out. Put the lid on, because that lid then is going to protect from contaminants entering the bottle. And then that means that that material can go round most efficiently through the recycling process. Another thing that you can do, in terms of recycling, and we are working very much towards trying to get this fossil-based or anthropogenic carbon out of the non-recyclable material to prevent the environmental impacts, is to, so Viridor was a founding member of the UK Plastics Pact, which is run by the Waste Reduction Action Programme, and it brings together representatives right across the value chain for plastics, and it's delivered on a lot of things, in fact, one of which we can see as we go and do our shopping at supermarkets, is that the carrier bag collection points that have been now expanded to incorporate all sorts of other laminated soft plastics. So if you're eating a crisp wrapper at the moment, excuse me, wrapped in material like this, laminated, metallic laminated plastic, or sweet wrappers like this, that can all be collected up and should be a deposit point at your local supermarket. And that then does go for recycling. This really does then support a move towards more plastics being collected more widely. So currently that material is not collected at curbside, but now there is an avenue for that material to be collected. So this is our process. We've created a virtual tour, and the link should be shared with you in the chat. So it goes through the 15 steps of treatment with text and video for each step. So almost 100% of the material that's used for the treatment comes out of the process, is a product. Sorry, almost 100% of the material that's used and that comes out of the process has a use as a product. So that's really, really increasing efficiency. So the front end of the process is that we put things into bins, and so do people in businesses. So we receive waste. Some comes to us in these kind of vehicles, the refuse collection vehicles that do the local rounds for housing. And of course, we do have commercial and industrial contracts as well for waste treatment. In fact, most material comes here in articulated lorries because it goes to transfer stations where it's bulked up, and then that then decreases vehicles on the roads and emissions from those vehicles. So we receive it and it's delivered into a store, and then the material is mixed to make it the best fuel that it can be and lifted up high so that it can fall down as it's burnt out through the process. So to show you some of the images then from within the facility, this is from inside the tipping hall. I wanted to show you the scale of our operation, and you can see that we've got a loader vehicle there that is responsible for keeping the tipping hall floor clean. We have 10 bays for deliveries. All vehicles arriving come through the tipping hall and reverse towards the bunker to deliver their loads. We can have up to 3 vehicles in the tipping hall at any time. So there's an awful lot of material. It comes to us actually first over the weighbridge, and of course that's where we have to check documentation and make sure that it is the right waste coding for us to treat, because we are here to treat just household type material. No clinical, no hazardous wastes are treated at this site. This is a view then from the control room. So looking down then on the store, so there are 2 grab cranes that move on overhead gantry rails, which mix the waste, and then it's lifted to deliver it as a fuel to the hoppers, which feed onto the grate continuously. So it's always operating our process, so 24/7. This slide shows you inside the facility, and there's a lot of complexity there. Hopefully you can just about make out that there is a person, an operator there. Then here is the one of the grates. So you should be able to make out there's a sort of orangey brownish area. That's a sloping grate that we have. And so once the waste is fed onto the hoppers, it falls down then onto the grate, and it's a combination of gravity and the operating mechanism of the grate itself that moves the waste off down the slope. So the blue ducts that you can see on this image are air ducts. And as I said, one of the most important things that we can do is that we can suck air within the facility from over the store, right the way through the tipping hall, and from within the facility itself, and then it's pumped into the combustion chamber. And it's that suction then that enables us to control odours within the building, and also it's there to supply oxygen, which is vital to getting complete combustion. So the waste is burnt at high temperatures. We must achieve over 850 degrees Celsius, and it takes approximately 45 minutes for the waste to be fully combusted as it moves down the grate. The top line then of outflow from this combustion is to generate power. So like traditional power stations, we use water to generate steam to drive a turbine, which in turn feeds the generator. So as the very hot gases then are sucked through a cleanup process, so we pump degassed and demineralized water in pipework through the hot gases in the opposite direction. And all the heat energy moves in through that pipework, so heating up the water. So the water turns into steam, and once it is superheated, it's safe for it to be sucked down to the turbine, which is shown here. So just behind that padded area, hopefully you can see in the photo on the left. So the blades of the turbine then spin, and that's hooked up through gears to a generator here. The electricity flows out through these cables onto transformers, and it is used to power our process, as I've said, and the rest then flows through cables and leaves for export via our local substation. So then the steam then condenses back into liquid water, and it's recycled again and again. The flue gas cleanup process is absolutely vital to our operations, and it's the middle line of our process diagram, and it explains, what's happened as the waste is combusted, how we clean the gases. So they are sucked through ducts as they're cleaned, and there are 3 processes, the first of which is within the combustion chamber, and that's where we inject urea pellets. That reacts to reduce NOx gases. Secondly, we use vibrations to suck down any particulates within the gas stream. And thirdly, we use 2 powders. They're injected for the reactions that clean the gases. So there's activated carbon and hydrated lime. We sieve those out through fabric filters. And then once that material has done its job, then it's termed air pollution control residue. And basically, the gases are sampled before and after the filtration system, and that's controlled by the computer system, so that we know that we are operating under our consented emissions levels. So here's the reality of these silos for the lime here and carbon. And then we've got the area where the air pollution control residue is stored, and this is below is the hookup where the off-taking vehicles come to remove that material. And this is an exciting thing because we have a contract with a company called OCO Limited, and they take that powder away to be made into products. So here you can see on this photo a carbon negative building block. So the lime still has some reactivity, and basically that reactivity then makes the difference from the air pollution control residue, which is a hazardous waste. OCO inject carbon dioxide into that powder, and if you like, it's like a quick limestone reaction, and that encapsulates everything within the pellet, and the pellets then can be put as a product into building blocks. And because it entraps carbon dioxide, they are carbon negative. So the final line of the process diagram then is what we do to treat the ash. So the ash drops off the grate and it's then processed into recycled products. So here you can see that it comes onto a vibrating table from both lines. In fact, the ash drops over a roller, which is controlling the flow of the waste as it falls down the grate, and it drops over that roller into water that we've already used at the site, and that's the start of the quenching process. Once it's been quenched and cooled, it then moves onto and is pushed out onto this vibrating table, which moves and collects the ash from both lines. And then we remove oversized things from the ash. So they are almost always metals, and that goes for recycling. And the smaller ash fragments then move on through conveyors and go under magnets, which separate out ferrous. That again then goes for recycling. So once the metals have been removed from the remaining ash goes on a short journey via conveyor to our co-located business partner, a company called Fortis. You should get the link for them coming up in the chat if you're interested to look for them. What they do then is they store the material here, and it's sampled before it goes in through their process works, and they remove more metals for recycling. And once they've done that, it's actually called incinerator bottom ash aggregate, which is an aggregate which can be used for road building. So it is in fact a product for use. So that is our process, and I'm going to hand over now to Innocent, who's going to go through with the control systems we got from environmental monitoring.
Cool. Thank you so much, Jess.
That's okay.
That was a good one. Good afternoon, everyone. So my name is Innocent, as been said. So I'm just going to walk us through a bit on Environmental Agency, Industrial Emissions Directive, and actually our permit here. So the Adley site is operating on Environmental Agency permits. And basically this permit is created for us to have a limit to whatever emission limit to whatever substance or particle that that is coming out from our operation. And basically these emission limits are being controlled by the IED, which is the Industrial Emission Directive, that tends to control all the pollutants that come from big organizations or large facilities that are into combustion, as we are here. So if you see on the far right there, that's actually our two stack emission points where the emission particles are being emitted. But it is not just emitted free to air. This is being controlled by the limits given to us by the Environmental Agency. And I just want to tell us, I'll go through a bit of our permit, and I'll be discussing based on both management, and I'll discuss based on the operations as well, what we do, and then I'll discuss a bit on emissions and monitoring and what we monitor. And then I will be telling us as well the information about recording and how we send notifications if there's any form of breach, just to let you know that we're being regulated heavily by the Environmental Agency. And every site actually that has a permit has a site regulator. So we have our Environmental Agency site regulator. So just to talk about in terms of responsibilities here. So we have, of course, the site manager here. We have the operations manager, we've got the engineering, we've got maintenance, and the EHS as well. So these are people whose responsibility actually includes to understand everything about the permit and be able to ensure that we confirm to that. And then we have our shift team leaders and their assistants as well, which we ensure that they understand the permit and our permit requirement and that they are conscious of the environmental impact. So our engineering team, the shift technicians, we've got the even the apprentice who join when they join us as well. We make sure that we train them on our permit management, and of course the tipping hall supervisor. So these are, like Jess was explaining, the team that actually receives the waste, which we call fuel, actually into our site, and they ensure that this whatever waste that comes in here actually has the right EWC code, has the right waste code, and then before in the weigh bridge before it actually comes into our site. So as you could see the picture there, we tried to keep it a bit real and show you our control room. And this is our control room where all monitorings take place. And it is a maze of screens there. And we've got continuous emission monitoring system that is constantly going on. And the team is monitoring, the site is covered with, of course, CCTV. And we monitor everything and monitor both periodically, and also we monitor continuously, which when I go further on, I will be able to tell you the ones that particles or parameters that we monitor in terms of continuously and those periodically. So just a little bit on management of our permit. So we make sure that the accident management plan is in place, efficient use of raw materials, and then just to talk about the environmental emission and the background on which we monitor whatever we are monitoring on site here. So we've got the best available technique reference, which is actually a document that its aim is kind of it's led to the establishment of extensive set of emission limit values, like I put it there. So this reference guides us all, even the incineration plants technology, to make sure that we are achieving D level emission levels that are set up for us. And so, like I was explaining, these emission limits that are being set up with that reference actually obliges us to have continuous monitoring of some substances and also periodic monitoring of a broader range of substances, which I will inform us moving on as well. Those particles to demonstrate that whatever this proposed very in an insignificant impact on the environment and health. So whatever is we have been allowed to emit has been, of course, risk assessed by the agency, and limits have been set, which is available technique, and make sure that we are even below those limits. And if there's any form of breach at the point where it occurs, we report these exceedances, we call them. So if there's any form of exceedance, we report it directly to the EA, and then we investigate that internally as well, and with, of course, the collaboration with the environmental agency to make sure that it is put in place and that we've corrected that. So Jace has talked a lot too about CO2. Well, basically from our process, as you all know, CO2 is of course being released, and there are strategies now, in place for us to actually go into carbon capture technology, which Jess was talking about, and initially at our Roncon plant. So this is now what the company moving on is trying to get into, is to see how we can actually go into carbon capture. Next slide, please. So just to go a little bit more on our operations. So in terms of our operations, we ensure that the waste comes in having the right EWC code before it's allowed. But at the same time, we are obliged to make sure that during the operation, that the temperatures that we are obliged to use here from 850 degrees is being maintained. And of course, we are being mandated to report all exceedances. So then in terms of emissions and monitoring, which I believe most of us will be interested in. So this site is in terms of anything going to the drainage, no water goes to the drainage. It's a bonded site, so that's all right. But in terms of monitoring, we have point source emissions, which and then we have process monitoring, and then we have the residue, which Jess was explaining, the ash monitoring, and I'll just tell us in a minute. So just in terms of fugitive emissions, we monitor as well odor. We're obliged to have an odor management. So we have odor suppressants here and making sure that we are not, of course, keeping the neighborhood uncomfortable due to the odor that comes here. So there's odor suppressant and odor management in place. And in terms of noise and vibration, we monitor this as well and make sure that we don't have any form of inconvenience, but to the people that live around and also, of course, to the environment. So in terms of monitoring, we have the point source monitoring. We've got the continuous emissions monitoring, and we've got periodic emissions monitoring. So I tried to give you as much information as I can there on the on particles that we actually continuously measure that goes through our stack points. So these are we've got 2 stack points that over there. You won't see it from the window here. So we are measuring things like our total carbon. We're looking at hydrogen chloride. We're looking at hydrogen fluoride. We're looking at carbon monoxide as well, and we're looking at sulfur dioxide. And we are obliged actually to have limits set, for us here on half-hourly average that's been set, and we have to meet that. And we have ones that are half-hourly average, and we have a certain amount limit that is being given to us to achieve or below actually, to get to in a day. So these are continuously being managed, the continuous emissions. And then if we go to particles that we look at periodically, so that's all there. It's a little bit small, but yeah, bear with me. So in terms of particles that we emit to air, that we periodically monitor, I've got them all. Just gonna see if it is a bit more visible there. Yeah. So we've got the nitrogen oxides there. So we've got all the dioxin and these are all periodically monitored. And of course, we report them basically to the environmental agency. So we report both quarterly. We've got reports for 6 monthly, and so we also have site visits where the environmental agency are always on our site, for just a visit, periodical visit, could be quarterly visit, and whatever report that is due. We've got a pollution inventory reports that we send across to the environmental agency. And I'm just going to go over. So in terms of ash monitoring, so when Jace was talking about the residues, and because we have what we call the bottom ash. So basically, after the whole process, the combustion of this material, so we have the IBA, we call it, and so these are the incinerator bottom ash, and we are obliged basically to have a continuous test on them as well. And then even after treating the gases as well that are being used, the flue gases that are being used, that are being, whatever we used to treat the gases that comes out from the combustion, those ones we call the APCR, and APCR is air pollution control residue. So these residues as well we are always reporting that to the environmental agency, and we have to make sure these are all being tested for things like dioxins and furans, and we have to ensure that we are all below limits. So just a little bit in terms of information recording, we are obliged to keep all records, and we are obliged to send all notifications. So if there's an incident here, like I would tell us about the last incident we had here, a fire in the bunker. So we had in the tipping hall, basically we had, which is why we keep flagging up the campaign for people. It starts with you in your house, what you actually put inside a waste bin and for disposal. So we have some firecrackers, and maybe the last time there have been a lot of barbecues and due to the summer, so people put in canisters and pressurized cans, and that causes us a whole lot of trouble here. Because in the tipping hall, we did experience a fire outbreak, but because we've got our emergency preparedness and response in place, we've got unit emergency plans here. Everyone is trained, and we have all the right response tools here. We're able to, and of course the CCTV monitoring as well. We're able to actually smother the fire before it caused a lot of issues. We had the fire brigade come anyway just to ensure that it was all okay. So this starts with just a waste from a home that could have perhaps had some form of canisters in it, or it could be battery. Think about it could be electronics that you wouldn't see, and that. So basically, we bought all this, and when the compliance classification scheme, which the EA uses to regulate and auditors, and in terms of points, of course we don't want to be in that red one, CCS one there on the major points. So it is our duty, of course, not just my duty as the EHS personnel here, but the management, that we want to make sure that we're all really going to no risk or minor risk as the case may be. Otherwise, the site is, everyone is here trained, and we've got fire marshals in place. We ensure, of course, that people are aware. We've got the emergency preparedness in place, our spill kits, spill response strategy are all in place, and we make sure that even the staff that work here, that every one of us can be able to respond and be able to point out when there are bad practices, and in that way we kind of audit ourselves basically before the EA comes, or before we have audits with BSI for our 14001 EMS or quality or energy management, as the case may be. So that's actually in a nutshell our operation within our permit. And yeah, thank you.
Great, thank you very much for listening, and we are hoping that we've got some time for questions. So it's over to you, Lewis, to answer, so that we can answer some questions.
Yeah, thank you very much. Thanks, Jess, and thanks, Innocent, for that really interesting overview of a really important topic. And yeah, we certainly do have some questions. I don't think we'll have time to get through them all, unfortunately, but we'll take a couple and see how we get on. So the first one I'm going to go with, because it looks like a good one to start with, is what's the current state of the recycled plastics market? Is there enough request for all the plastic you recycle, and what's the main use for it?
Well, that's a really good question, very interesting question. Basically, I think that if we could produce more our plastic, then we could sell it. It's like an open door. There's a huge market there. We can't really process enough of it to keep it here in the UK, basically. That's why our company is certainly looking at opportunities to invest in more infrastructure here, so that more can stay within our group of small islands and not be, shipped.
Yeah, so there's plenty of market for it. And have you got any indication or idea as to what the main products might be that it goes to?
So,
any examples?
so currently, we can produce the 95% purity for milk bottle to milk bottle recycling, and you need 99% purity for these drinks bottles, the PET recycling. So we can produce that material, but really what its main endpoint is at the moment is to bottles for detergents. that kind of thing. So it's not to be imbibed basically at the moment. That's where it's at, and there's enough of a market there, you know, for that material just to go straight to them.
Great, thank you. Next question. Might be a slightly trickier one, this one, but we'll see how we go. For the waste hierarchy slide, what percentage does A, the UK, and B, Viridor currently have going into each subgroup? So I suppose, yes, the question is what percentage of material gets recycled opposed to being diverted either to landfill or an energy recovery facility?
So that's a really interesting question. So in terms of householders, recycling has actually slightly decreased recently. It's currently around about 45% of materials. So that's some percentage. And of course, then there's commercial and industrial waste as well, where I think that the recycling levels are not quite as significant, in fact. I think for some materials like building sites, that the recycling has got much better. I think I'm just trying to think, it's very difficult to actually put figures on it in terms of percentages. What I can say is that there is a substantial amount of material, millions of tons of non-recyclable waste that is slightly processed as a fuel, solid recovered fuel. So its moisture content and calorific value is fixed, and it has an end contract before it is exported. But significant tons of that material is exported from the UK. And of course, the environmental impact of that is much bigger than treating it right here. So I think that's, for me, that's something that we really need to work on, as well as increasing levels of recycling.
Great, thank you. I think we've got time just for one more question, which is, sorry, let me just find it again. What is the source of carbon dioxide to the building blocks to create the carbon negative materials? Is the CO2 trapped, filtered and mixed?
So, well, that is, do you know what? I don't know the answer to that question, because that is OCO's process. And so their source point, I don't know, I have to pick up with them. What I would like to talk about in terms of, carbon dioxide is that in waste, there's basically the carbon there is in two forms. Firstly, there's the form, from the natural cycle, which is perfectly in balance, which is from paper, cardboard and cotton, that kind of natural textile material. And then there's also the anthropogenic carbon, which is in the plastics. And of course, for us, in terms of capturing the carbon dioxide, it's the anthropogenic carbon dioxide is the one that's the real problem, because that's what's putting our atmosphere out of balance and increasing the amount of carbon dioxide in it. Whereas the one that's part of the natural cycle is actually in perfect balance. So when we are talking about capturing carbon dioxide and all the carbon dioxide from treating non-recyclable waste, we've got both the natural life cycle, one in balance, and the anthropogenic. And so in terms of the benefits, it's actually making sure that we get plastics out, more anthropogenic plastic out of the waste, and create less of that really, really helps to reduce the impacts in terms of carbon emissions. But when we entrap both, then of course, because we're going to be pumping down and trapping, capturing the one from the naturally balanced cycle, it's equivalent to taking carbon dioxide actually out of the atmosphere. And that's where we're going to get beyond net zero to net negative, which I think is a really, really interesting thing.
Yeah, no, really interesting point, and maybe the topic for our next talk. So, might have lined yourself up for another talk there, Jess. But no, that's great. Thank you. So yes, thank you. I will start drawing it to a close because I'm mindful we've reached the end of our time. It's been really interesting talk. Big thank you to Jess and Innocent. Thank you very much for that. Thank you to Olga and Natalia for supporting us on the technical side of things. And thank you to everyone for joining us. Apologies we didn't get through all of the questions. I will make sure that Innocent and Jess see those questions. Yes, just to finish with a final big thank you to Jess and Innocent for presenting today. Thank you very much, everyone, and enjoy the rest of your days.
Thank you.
Thank you.